Other topic that we'll deal is identifiers. Okay, so this is the topic that we'll have to name things. For example, you have to give variable names. We'll look in what variable means. We'll look in what functions means, what a class means, what an object means, everything that we'll look in. But we have to name these things. So there are various entities such as classes are there, functions are there, variables are there. So first thing is you have to name them. So any name given to this class, function, variables, they are called identifiers. Okay. So basically, the word itself, identifier, means you are using it to identify something. For example, if you are naming some function, you will write def. Def is actually a keyword. Then you'll name the function. Okay. And there are certain rules for writing these identifiers. If you see, you can use combination of characters, both lowercase and uppercase, and digits from 0 to 9, and the underscore. Okay. This is the first rule. Rule 1. So rule 1 is you can use combination of characters, uppercase A to Z, lowercase A to Z, digits from 0 to 9, and underscore. If I show you the coding window right here, so here you can see it. For example, I have mentioned my variable here. It's a variable. So my variable, it is using the lowercase letters and this underscore symbol. So if I run it and if I print it as well, for example, I'll also print it. Print my variable, let's see. So here you can see the value of the variable was 42 and the 42 was visible on the screen as well. So this is the first rule. The first rule was that you can use the combination of lowercase letters from A to Z and uppercase letters from A to Z, digits from 0 to 9, and an underscore. And the rule is you cannot start the name of an identifier with a digit. So you cannot use a digit in front. You can use digit maybe at the end, but you cannot use that at the front. So for example, if I show you in the code here, this is my variable. I haven't started with this. If I write my variable, you will see it will give me the error. Invalid decimal literal. Because this is not allowed. You cannot start the name of the identifier with the numeric letters. You can though write it in between or somewhere. So for example, you can write it here. You can write it in between 1. You can write 1 here. It will be easily able to print this. So if you see it here, so this is 42. But the second rule says that you cannot start an identifier with a digit. So this is not for here. I have mentioned that one variable is kind of considered as invalid. Okay. So you must start it with either underscore or uppercase or lowercase letters. You cannot start with a digit. Then you cannot use a reserved keyword. For example, if you want to name a variable, you cannot use a reserved keyword. So if I by reserved keywords, I mean, for example, here I have for. For is a reserved keyword. If I see it here, you cannot use it. It will give me error. Okay. So here I have used for is equal to 5. I use it as a variable name. If I just run this cell, it will show invalid syntax. So you cannot use reserved keywords as your identifiers, as your name of the classes, functions, and things like that. Okay. The other thing is you cannot use special symbols. You cannot use special symbols like exclamation, @ pound symbol, $%, and other symbols like that as identifiers. So it will give an error. So in the code, if you can see, if I just run this as a special symbol, @ for example, I have just mentioned @ special variable. This should give me the result invalid. You can see it's invalid. So you cannot use @ even you cannot use percentile. If I use %, again it will give me some error if you see it. Okay. If I write exclamation, this is not allowed as well. Anywhere this is not allowed. Not just in the start, it's not allowed anywhere. So if I write exclamation here, it's not allowed. Okay, so broadly, I'll again reiterate the rules. Whenever you are naming a thing, the first thing is it should be a combination of small a to small z, and then capital A to capital Z, and digits should be 0 to 9, and underscore is allowed. Okay, and variable name cannot start with identifier name cannot start with a digit, and reserved words cannot be used as identifiers. I also showed you the examples in the code environment as well. Here I have written them as well. Okay, so what are the topics that we learned so far? The first thing is we learned what is Python, what are the applications of Python. Then we saw a little bit how to write good code, what are comments and things like that. Then we'll move to variables. What basically a variable in terms of Python mean. These things what I'm speaking are really generic terms. They're not specific to Python only. If you see. So these things are also in other languages as well. I'm just like putting them into the right context. Where are they used and how are these things used in Python? But if you speak in other languages as well, there are same concepts as well. Okay. So let's now go to the concept of variables. What is a variable? So in Python, variables basically are memory locations. If you see it here, they are just used to store some data. So if there is a for example, everything in the computer is basically stored in computer memory. So there are a lot of types of memory, secondary, primary, there is RAM, registers, cache and stuff like that. So there is a lot of types of memory. So usually in the primary memory, these memory locations, so if I have to store, for example, my name, this is a variable name. So when I assign it, for example, a string Musawwir, so what will happen is, in the memory, it will just create a block of memory and it will write this Musawwir into that block. Okay. So if anyone asks you what is a variable is nothing, just a memory location that is there in your PC. Okay. So it distinguishes other memory locations as well. For example, rules of variables are the same. When you want to create a variable, the rules are of those of identifiers, which we saw. For example, in here I can write, if you can see the coding environment again. So there I have written a lot of definitions as well. You can just read them out. But the first thing is variable. If x is a variable, I have assigned it 42. So this is assigning an integer value. So 42 is an integer value. It's a real number value. So we usually call these as integer number 42, 43. I assume that you know the definition of integers. So for example, name, I have assigned it John. So this John is a string. It's basically a string data type. So again, is valid. Again, all of these are variable. X is a variable. Name is a variable. Is valid is a variable. Okay. So this is an integer variable. This now is a string variable. This now is a Boolean variable. Okay. So how I have claimed it, there is a function known as type. Okay. So if I have assigned x is equal to 42 as an integer, I have given name John, that is string. I have given a Boolean value. Now I am storing their types in this type x, type name, and type valid. I am storing their name, their types. So when I write this, so you can see this x is a type of integer class. This name is a type of string class. This is valid is a type from Boolean class. So if you don't know what these classes and objects means, Python, basically in Python everything is an object. So that's why it's called pure object-oriented programming. So in the future sessions we learn what an object-oriented programming means. But here I want to show you that. So this variable can be of any type. It can be either of string type, it can be of integer type, it can be Boolean type. Okay. So variable basically is nothing but just a memory location if you see it. So whenever you are creating some variable, I'll show you a beautiful thing probably. I'll show you, and that, for example, if I write x is equal to 13, okay, and I want to see its memory location, I'll say print, let's say id of 13. Id of 13 will give me the location where this x is. Okay, so it is giving me the location of this x is equal to 13. If I write and the block, if I write y is equal to 45, I'll again write print id of y. So this will give me the location where y is. Okay, so here I got the location, and you can see the locations are pretty much different. But let me show you something. If I write x is equal to 13 also, if I run it again, can you see these locations are similar? But still the name x and y is pretty different, but the locations that came out are similar. So can anyone answer why is it so? Okay, so you are saying the value is same. So what happens if the value is same? It's in terms of CS. Let me just show you some magic. I'll say 12560 something like this, and I'll copy it, and we'll see if these values are similar as well. Can you see the locations are different? Because these values were same. So when I just wrote 3 previously, I wrote 3 here and 3 here. Let's run it again. You will see the locations are pretty much similar. Not pretty much similar, they are actually similar. They are equal actually. But when I wrote these numbers, when I checked the locations, you can see the locations are different. So there is something sorcery going on. Koi jadugiri chal rahi hai if I have the values. Whenever you give an answer, I am trying to defend myself. No, this is not right, and why is it not right? And probably you are partially correct as well. So any other answers? Why is this happening? If I am giving the value, let's say even I am giving the value 10, or I am giving the value 10 here. So if you see in the both of these cells, when I run it, it is showing some ID, it is showing some location, and then when I am again running it, it is showing again the same location. I think fives were fives, huh? You now hit the right nail. Right. So what happens actually, there is a range. So if a number is smaller, that's what phi is meant by there are less number of bits. So what Python does is Python basically stores it. And when we define that thing again, so what it does is if a number is less than a certain range, you have to check that range in the documentation. If it is less than that certain range, then it will reuse that location. Otherwise, it will create a new variable because looking takes a lot of time. So for example, when I write 10, so this 10 gets created in the memory. Then when I had this x points to this 10. So when I again use y is equal to 10, what happened actually? So this was a smaller number. So the thing that happened is this 10 was already there. So it just pointed and the pointer towards it. But when I had number 1, 2, 6, 8, 9, 2, something like this. So this number got created initially. It was pointed x. Now the creators or inventors, they have made a choice that when there are large number, we won't search through the space. So what they did is when I again said y is equal to this number, so it won't create a new it won't create a pointer only. It will create a new location as well. Actually, I have tendency to go into the compilers of what happened there. So I don't want to bore you with these things, but you can see this thing. It can be a good interview question as well. If somebody wants to test your Python knowledge, okay, why are these so? So you can say that till a certain range, Python looks for the things that are inside it. But after it goes away from that certain range, it does not look. It will make a new object basically. Am I clear? So now we'll go to this variable assignments. How we assign these things to the variables. As we saw previously, we can assign an integer value. You can see it here. For example, age. This is a variable. Variable is just now a memory location. So when we are defining a variable, we're actually giving a memory location that we want something to store in. So this age we read is equal to 30. That means I'm assigning an integer variable. So if I have this price basically is a floating value. By float means that it has a floating point. So there is a separate class for this. So you can see that we're assigning 19.99 in here. So this is a floating point number. So we're assigning it that way. We can assign strings as well. You can see this is a string. Okay. We can assign a longer string. In the greetings, I have assigned a longer string. We can assign a list of numbers. You can see this. There's a list of numbers. Okay. So if you see it in the code, I have also can run that cell. So assignment can be of any type. It can be of any data type. So if I run it, you can see it. So I have just printed the age. For example, my age is 31. Because here I have reinitialized it basically. The first value of the age was 30. So then when I ran it again, it scrapped the value and again overwritten the value. So if I just comment these things out, so now the age will be 30. So you can have a reassignment as well, what we call reassignment. If you want to assign something initially and then you want to change it, so you can reassign that value to the age. For example, if I just do like this, age is equal to age plus 1. I think whoever is comfortable with the other programming language, they'll know that this variable age will get updated to 31, as you can see. Okay, so if I am printing this line right here, for example, below this age, so it will print the value of this age. The age is 30 when it was printed here. So from here we learn that it goes line by line. So when we reach this line, so it showed the new value, the value that we reassigned it actually. Okay, so this is the first type of statement, assignment statement that we do. Then we have multiple assignment statements. Okay, in the multiple assignment statement, I mean that I can create many variables and I can assign them different values. For example, if you see this, I have written a comma b is equal to 10 comma 20. This 10 will get assigned to this a, this 20 will get assigned to this b. Okay, I can write like this: a comma b comma c is equal to 10 comma hello comma, for example, some other floating point number 19.99. So this is the beauty of the language. So you in a single statement, I did a multiple assignment. So this a will go to this 10, this b will have this value of hello, and this c will have the value of 19.99. So this is how you do multiple assignments in Python. So if you see it here, for example, a and b, let me print a and b. Print a comma b. I'll just print these two values. You can see the a is equal to 20. I can just write hello to this. I can assign hello. So you can see hello and 20. Okay, I can even assign a list. For example, if I write C here, so I'll assign a list in here. For example, 1 comma 2 comma 3, and then probably I'll close the list and you can see it, and now I'll print the C. So what I'm saying is, for this first variable A, for the second variable B, for the second variable C, I did a multiple assignment statement. By multiple assignment statement, I wrote that hello will get assigned to A, this 20 will get assigned to this B, this list of numbers 1, 2, 3 will get assigned to C. When I print this ABC, you can see the results over here. Okay? So that's what I mean by multiple assignment state. You can have a single line of code and you can do the multiple assignment there. Okay, I think we have discussed about the storage locations as well. What storage location means, basically how they store it. So I've also shown in the example, if there are smaller numbers, Python basically looks into its memory if there is a smaller number present. So then it does not create a new object. So if a number is bigger, then it creates a new object. Okay, so that's what is the meaning of storage location. If anybody asks you what is a variable is nothing but a memory location in the Python's memory. So if you want to delve deeper into this, there are different types of memories as well. So there's a memory type called as heap, for example. A stack memory is there. So we don't want to delve into those things because then we'll go too deep into compilers, how these work. I just want to give you the first-hand experience of the things. You might have already learned these things into other languages, but I just wanted to put them in the perspective in terms of Python.